All right, welcome to the second official episode of this series where I will be jailbreaking a Roomba. Last episode we talked about safe motor selection, and so I brought two examples of 12 volt DC motors to talk about. Now these two motors are actually identical. They're the same make and model. I bought them at the same time from the same supplier on the same purchase. So these are about as close to two identical motors that you can get. One thing that's different about them is what's on the output shaft. You can see here, I've got like this little press fit hex adapter. I use this for another project. This was actually part of the Roomba, my capstone design project. You can see more about that in another video. But essentially this allowed me to create like the shooter mechanism on our flywheel. One thing about that system is we bumped up the current a lot on that shooter. One way we can sort of see the maximum expected current we can do is we can do that same trick we did last episode when we were talking about safe motor selection. Take out our digital multimeter, swap it to the resistance measuring setting, and take a look at the value of resistance across these leads. So first thing we're going to do, this one it's pretty easy because they're already separated out, but I'm just going to probe these two pins, and if we remember last time, the resistance had a certain value, and that value I no longer have written down, so I'm going to struggle to probe this a little bit. And so if we look, the total resistance of the coil inside the motor plus the wire that connects it is 0.6 ohms. We plug this into a 12 volt circuit, and we can use Ohm's law. We can divide 12 by 0.6 and get an expected measurement of the current. I realized I forgot my little calculator, so I'm going to pull out my calculator real quick, and we can say 12 divided by 0.6, that's 20 amps. So this is like the maximum safe sort of current we can really apply on a rev hub. This is like the maximum motor that we can safely do with that rev hub without bursting the fuse on our battery. So we're expecting to see 20 amps of current through this. It's a lot. That's why it was so powerful. If you remember, I was talking about like feeling wind coming out of the back. It's pretty cool. If we are to measure this motor instead from lead to lead, one thing you may notice is that this wire is thicker. So generally, thicker wire has less resistance. There's a bigger mean free path for the electrons to go through, and that means that the resistance of the wire is lower. And so if the resistance of this wire is lower, the coil also has a resistance, but we can expect that this whole system, it has the same length of wire but thicker wire. We can expect this system to have less resistance. So just going from 16 gauge wire to 10 gauge wire, let's see how the resistance changes. So on this one, if we probe it, we see it's changing 0.3 ohms. So this is half the resistance. No, 0.2. It's a third of the resistance. So since it's a third of the resistance and the resistance goes in the denominator, we can do some mental math and figure out that this motor, we would expect to see 60 amps of current flowing through it, which is a lot. This would fry the rev hub. So if we crimp these connectors on, we plugged it in and we tried to run it, the fuse in the battery would probably be the first thing to break out. If any of that current made it through the rev hub, if you sent 60 amps through that, you might damage your components. So I bring this point up because we are putting a bunch of unlicensed motors on the rev hub. The goal is to put 4 unlicensed motors on this rev hub. We're gonna need to make careful measurements of the coil resistance and any like wire connections that I'm putting on the system, just to make sure that we're actually putting safe voltages through the system. Safe current, not voltage. The voltage is going to be 12 volts, right? So that's our battery voltage fixes that maximum voltage we expect. But the wire resistance and the coil resistance is what is going to affect that max current. And so let me go ahead. I'm going to take this off set it to the side. And I'd like to show you now the actual parts on the Roomba that we're going to modify today. So I actually did some work off camera, and this is the drive pod for the Roomba. This, you'll notice, has 4 wires coming out of the top, and the way I set this up is the red wire is the native signal from the Roomba circuit board, and the blue wire is my spoof signal. So this is like the hack that we're inserting. This white and blue wire connects straight to the actual motor, but by removing the signal wire from the circuit board first, we can intercept that signal and decide if we want to use that signal or my signal that I'm going to be giving it with the controller. And so we've got this one. This is unmodified, and I'm going to show you all the modifications I made to make this. Now, you might be thinking, why didn't you just show us this in the first episode? Why did we do the other motor? The leads on this one are much smaller. You got to be much more precise, and so if you've never practiced soldering leads that small, it can be very frustrating. I would recommend you get some practice before you jump in if you want to do something like this. And it's also good to have some extra tools. So you might want to have like a soldering vacuum, a wet sponge, or a steel wool. And those will all help you make sure your soldering iron is clean and everything works well. So let's go ahead, let's start actually modifying these parts on the Roomba, as we will need to. And let's talk about the tools. So we're going to keep this digital multimeter on hand because we want to measure the coil resistance throughout the process to make sure that we're not breaking anything. That's one clue that you created a short or anything, is if you're measuring resistance throughout your process, you measure a 0, you go, oh crap, I gotta roll back. So we're gonna keep this. This is our sanity checker. Of course, we are going to need solder and a soldering iron. We are going to need the actual wire we want to insert in, and so I've already got it here. And because we're using wire, we're going to need wire strippers, of course. I like to have little extra pliers in case I need to bend wire. This white and blue wire is a little stiffer than the red and black wire, and so it's nice to have this when you get like the small little sections that you need to bend over. So we got pliers. And we're also going to need to disassemble and modify the casing. We're going to need a hand file and a precision screwdriver set. I got this precision screwdriver set from Harbor Freight, and one of the problems is that this hole right here that you can see on the motor is too narrow to really fit the head of the screwdriver in. So if you look on the right, this is the one that I modified. You'll see that I sort of added that taper to the top of the hole, and this one is untapered. So the first thing we're going to do before we can really take this down is we're going to pull up our trash can. And anytime you're filing like a plastic, especially a metal, I usually eat at this table. I don't want to get forever plastic dust on my food or my table. And so you just take this. It's probably going to take like 3 passes. Which is like 1, 2, 3. And you see we already kind of widened that out. That's one side, and then we'll do 1, 2, 3 passes. And so if you use good technique, you're using good force, and you just push on it, it really shouldn't take that many passes to get this done. Plastic's pretty easy to cut with a file, so I'm going to take one more pass on the right. Just try and get it equal. And look at that. Seems pretty alright to me. And so with that, I'm gonna brush any remaining plastic off my file. Be careful doing this. If you got soft hands, it can hurt them. So that's it for the file. And now we can go, let's clear our workspace a little bit. Just get everything out of the way so we can at least see what we're doing. We won't need these for a little bit. Won't need the wire for a little bit. We're done with the calculator for now. And we're going to take this out. It's already just got like a standard Phillips size 2 on it. That's going to be enough. And as you see, we can get to the screw now. So, couldn't do that before with this screwdriver. Again, I'll show you the 3 screws that we're trying to remove. So we are going to remove one screw that's deep in this hole, one screw that's right here, one screw that's right here, and then it'll come apart. We're going to get our little tray so we don't lose anything. And we are off to the races. One thing about unscrewing these things in plastic, all these screws go straight into the plastic, they tap into the plastic. They can get stuck, and so one important technique is just making sure that the path of your screwdriver kind of passes between your hand. One thing you don't want to do is slip and jab yourself. That hurts a lot. Don't do it. And also, if your screwdriver's ever touched lead or anything, it can be like a very serious health hazard. So definitely don't do that. Always be very careful when screwing or unscrewing. And again, you want to try and hold your thing so that path of your screwdriver, see, kind of doesn't point at your hand. That's the safest way to do it. It would be even safer if I had like mounted this project to a table and I was using that as work holding. But this is pretty small, and that's it. So now the two halves of this gray casing are coming apart. As we take it apart, let's shift a little bit. Ooh, you gotta be careful. I'm not sure what fell out, so we're gonna have to investigate that. But we might have to refix something. That spring comes off, and we're open. So let's see what fell here. This is the part that fell, and it got bent all nasty gross. This is part of a limit switch that goes on. And one extra thing I'm gonna need to do, because I worked off camera and I made a mess in here, is I'm gonna need to peel off some extra hot glue that I put to stabilize wires that are gonna need to come out. So hot glue is coming out, and then we're gonna take a minute to show you how to put that cap to the limit switch back in. It's also gonna need to be bent back into place because I accidentally bent it pulling it out of this closure. It's a whole mess. We'll fix it shortly. Okay, so almost done, almost there. If you ever have to get hot glue off of like a PCB like this, an X-Acto blade is nice. So I'm gonna grab one. Got my X-Acto knife. You shouldn't need this if you're doing your own thing. But if you try to put hot glue on your wires like I did for whatever reason, this is a good way to clean them off. Okay, so we just kind of scrape. And so the thing we're going to have to do is we're going to have to target these leads on the side of this green PCB that I'm working on. And we're going to need to remove the old wire. We're going to connect that old wire to our output, that information cable that we're going to send out. And then to the empty lead that we removed that wire from, we're going to insert our little hack wire. So that's the one that sends our signal for our stuff. And then we will be back in business. So I am almost clear of the hot glue. And hot glue can be such a mess. It's really good for sealing up electronics when you're done, but if you're not done and you do it too early, it gets to be pretty bad. So always wait until you're complete to start hot gluing stuff down. And then we are is we are finally done removing all the hot glue. So let me show you a look. Here's what we got going on the inside. This is the motor. This is a little PCB that attaches all the leads. Inside here is where the gear reduction is that spins the wheel. Here, this is the native connector that sends the instructions to the Roomba motor from the Roomba control board. And this is the limit switch. So when this limit switch is clicked, it activates the signal. And basically what that's saying is that the wheel is fully extended. So if the wheel was not in contact with the floor and the suspension was fully extended, it would know that there's some sort of error. So that limit switch is supposed to be engaged while it's driving. If it's not, or that limit switch is supposed to be unengaged while it's driving. And if the limit switch is engaged, that means one of the wheels has left contact with the floor. So I accidentally bent mine. And so I'm just gonna take the pliers and kind of bend it back into shape. And you just use a little finesse. You can break these things by fatiguing them if you bend them back and forth too much, so try to do it right the first time. And straight enough is straight enough, so that looks good to me. And if you look at the tip of it, it's got those sort of like notches, and so it's going to slide into the slide, and then you push the other one in, and that's how it fits in. So if yours pops out when you're taking this apart, you'll know that you can put it back in. It's not the end of the world. If you really have trouble getting to it to like fit it in, there is also a screw on the limit switch that you can use. I am just going to try and finesse it in, so not like the best approach, but it is an approach, and I think it's gonna work. So there we go. I was able to just kind of slide it back in, and you look, works as usual. There we go. Limit switch fixed. Next thing we're gonna need to do is we're gonna need to start cutting and tacking into wires with solder. So I'm gonna pull you a little closer, get a better view. And let's start on this thing. So soldering iron is getting heated up. Wire is coming out. And if you look, I was nice to myself. I already stripped some decent length off all of these. We're gonna put our razor blade to the side. We're gonna put our pliers to the side. Pull our solder. Put parts in the bag. We're done with the screwdriver for now, so I'm gonna put it back up in the box, close it, set it aside. And our soldering iron is just about heated up. So the first thing we're gonna want to do, we want to pull these wires completely out if we can. Might be a bit of a challenge. Since these are mounted both through the holes and soldered onto the lead, the easiest way to do this is just gonna be trying to touch the lead, see if we can get it to melt, while we tug on this wire from the opposite side. This may work, this might not, but look at that. Come on, just a little bit more. There we go. So we pulled this wire out. That was pretty quick and painless. And just for the sake of being nice to ourselves, you see how we messed up this lead? It's no longer like a very nicely shaped ball, so we're just gonna heat it back up and let surface tension pull all the solder back together. There we go. Now it's a nice little trace again. And then we're gonna do the same trick on this red one. So we just, ooh, careful not to touch plastic because you will melt it. You gotta be pretty precise here. So heat up the lead, pull out the wire. That one was very smooth. That was a little more professional than I think I usually am with soldering. One thing to worry about is these traces have to be small enough that they don't rub on this part when it's closed. If you make your traces too chonky, it's not gonna work. Hate to break it to you, but you do need a little bit of finesse. It has to be the correct size on here, so I'm gonna try and scoop up a little bit of extra solder. And I don't have a great place to put it, so I'm gonna recycle. I'm gonna take that solder and put it on the end of these wires is tinning. So I just pull my wire over. It's still dangling on the tip of my soldering iron, so I'm just gonna leave it there. But I wanna, make sure these wires are nice and spiraled up before I tin them. Just because once they tin them, if there's any hairs hanging off, it's gonna hold those in place too. So go. There we go. We just put the little blob of solder on our wire. Psych, fell off. There we go. Put the little blob of solder on your wire. It's a good way to recycle it if you ever have a little extra just stuck on there. And then we're gonna go ahead, we're gonna tin up these wires too. Drop. So, and again, you want to heat the wire mostly more than the solder. You kind of just pull the solder in when the wire's hot enough to melt it onto the surface. Just this little back and forth wiping motion usually works pretty nicely. And you got to be careful you don't heat up the wire too much. This is copper wire. It transfers heat as well as electricity. So if you're holding this and you're really working on it for a while, you'll start to feel the heat where you're grabbing it. You may notice I've also got a little air purifier on my table over here, so I'm gonna kick it on right now. Now's a good time. I don't like lead fumes. Feels pretty bad for your bones, I'm sure. Not like speaking from experience or anything. I've never had lead poisoning, but that's not a good thing, I'm told. I'm told lead poisoning is pretty bad for you, so don't lick your fingers or anything during this process. That would be bad. Yep, there's tin in the wires. These don't really need it as much, so I'm gonna be a little haphazard about it. Having some is nice for adhesion, but not absolutely necessary. Pull out this other one, give it the littlest tinning treatment. And there we go, so that's it. Now, the thing to try is we're going to insert these hack wires that have just been tinned. I would like to do the blue for the ground and the white for the red lead, I guess. Red in air quotes because it's of course white, but serves the same purpose as that old red lead. So now we've got our wire through, and this is where I'm going to use those pliers and I'm going to bend it on top of the place where I want the lead to be. Because lead is so malleable, I can kind of just smush it into the trace like you see there, right? And so now when I bring it up, when I bring the soldering iron over and start heating up the solder, it should just wick onto that wire and make a pretty solid connection there. And would you look at that? Oh, almost perfect the first time. A little bit more finagling, a little bit more smushing, and a little bit more heat. And that's a good trace. So that right there is our first wire done. We're gonna go ahead and kind of bend it out on that route that it's gonna follow out. Look on the top. You want these to look very clean. You don't want any of the blobs to run into each other. You don't want the wires to cross the other leads. So it's worth keeping everything nice and neat here. And it is actually necessary to keep everything nice and neat here, believe it or not. So we get this, we got the white wire through. Now we're gonna bend the white wire over and just try to smush it right on top. Again, lead is malleable. Ooh, Lead is malleable, so you can kind of smush it right into the trace. And you don't want to use so much force that you like damage the PCB, of course, right? But you can kind of just smush it. Lead is a softer metal. So. And then just heat. Try to keep your trace flat. You don't want it to interfere with anything. And bada bing, bada boom, that's it. So that's both of our hack wires that are inserted right there. Their traces from the factory definitely look cleaner, as you might expect. But what are you gonna do, right? So that's them, this is me. If we want, we can go in on the other side and put little blobs of solder on the exit of the wires too. That'll make it more secure. Might not be necessary, but I'm gonna see if I can do it. So just and I cannot do it. So I'm not gonna worry about it. I'm gonna stop while I'm ahead and leave those there. Next thing, so we've got these wires, and if you look, I'm gonna double check these wires for health. I'm gonna see if there's any slits. And if you look, there's a bit of exposed wire here. So I don't want that. I'm gonna see where it's exposed, and because I'm already going to cover these with heat shrink when I close them up, I'm just gonna cut it off right there. But this is the native wire, right? So this is the wire that came from the Roomba circuit board. So we trim it, and again, you don't want to trim it too short because you still got to wire this out. And then we're gonna strip it, and again, these are spacing's getting pretty tight. You got to be a little precise. There we go. So now we got two tiny strip wires. These are going to connect to this. And I'd like to get my heat shrink on before I do that. The heat shrink stuff is easy. You've seen that before. But of course you gotta grab it. And it's nice to have some scissors. We're gonna take the smallest size I got. And we're gonna need the heat gun too. Oh, took out too many. And I always like to fold it in half and cut it. There we go. And you slide it on. Again, you got to make sure you leave enough space away from the interface you're soldering so that you don't activate the heat shrink too early. The heat will travel through the wire. This isn't copper wire, so the effect is a little less, but still transfers a lot of heat. Got to get the heat gun too, so we're gonna do a quick little battery swap. Since these are already tinned, oh, I did that too early. It was premature. All right, we need to solder the wires together before we can really do that. This isn't really best practice because I'm just floating in the air, but I think I'll be able to just get that little tack on. It shouldn't be too hard. Sorry, pretty bad camera angle. Yuck, yuck, yuck. This is not very fun. Okay, so we're gonna put a little more solder on the wire. Make it a little more receptive to that bond. And now we're gonna take two. Okay. Oh, why'd you get all tangled? Oh, there might have been a little bit of hot glue there that reactivated. That might have been it. It's important to have your heat shrink on before you do this because you can't, well, these wires are exposed at the end, so you could run it all the way, but much more convenient if it's already on there. I'm not getting a very good bond here. Woof. Okay, so that's pretty bad. Let's see. We can definitely do better. It's important not to be a perfectionist, but if you're not doing the job, you kind of gotta do it. This isn't even perfectionism. I'm just trying to do it. All right. Alright, that's it. It looks kind of nasty. Well, we'll see. I mean, we'll have to measure the coil resistance and all that. Make sure it's safe, but for now we just slide our heat shrink over. Make sure we're covering any exposed wire. On that black wire we do have that problem spot. But there we go. Got the heat shrink on. Now you can heat it and shrink it. I bet you'd never guess that heat shrink shrinks when you heat it. There we go. So that's it. That's all the wiring we actually needed to do here. One thing that's nice to do, it's going to route out through a specific aperture that's already built in. The manufacturer actually built this in, so we didn't have to drill any holes. It's nice to coil your wire nice and neat. I like to wrap this red and black wire that's more flexible around this bend and stay wire, this more rigid white glue wire you see coming out. And it gives it like a very nice structure. Then we're gonna have to fish it through, so we put it through that hole, that big square hole. We just feed it through. And as we assemble it, it should just go right in. This is a good place to pause because the spring that does the suspension is going to be so much easier to put in while you're in this part of the process rather than another. So make sure you get this spring. It's going to hook around here and here. So we're going to take the spring, we're going to hook it around one, and we kind of start closing it and then pull it around the other. And it's a pretty vicious little spring, so be careful about your fingers. Don't lose any fingers for this. This is also a good use for the pliers, so I'm probably gonna use mine real quick. I was hoping I'd do this right the first time. This part is always just annoying to do. On the other, jeez, H cookies. On the last one I did, it didn't give me this much trouble. On this one, it's just a skill issue, I guess. Let's try a different technique. We're gonna try doing a weird route. Let's do that. Well, so the spring's on, and then you kind of twist it. Oh yeah, look at that. Okay. Let me make sure our wire is safely routed out. Make sure that it's not like exploding or anything. Okay, so now we're just holding it closed. It's not wired up or screwed in yet. I'm gonna pray that it stays assembled like that. It is spring loaded and it's not screwed together. This is making me so nervous. I shouldn't be doing this. But I don't want to go through all those screws. Okay, I'm squishing it back together, making sure it's staying assembled. I want to measure the coil resistance before I really get too excited about being done with this. And we should be looking for somewhere between, like, I've seen numbers between 40 and 60 ohm for this particular coil resistance. So we got it set to measure resistance. Oh. 12 ohms? See, that's way too low, isn't it? Let me measure the other one. So this is the other one that I did. Let's measure the coil resistance there. 29. What? So if one's 12 and one's 29, that means. Let's see if me touching the wires was messing it up. 12 and 29. Oh gosh. Okay, so I think that means we did something wrong. If this one is 29, this one should try and be around that much too. So we're gonna open it back up, make sure that we haven't shorted any wires. And we have, so if we take a looky here, you see this part, that's nasty. That's connecting from one lead to the other. So I'm glad we checked that. That is actually wrong. We're gonna need to fix that. So we pull this out, we look at the nasty lead. Let me see what I can do about that with the razor blade. I think some of it was obscured with hot glue before, so I couldn't see it. So I wasn't 100% sure if it's hot glue or the actual the lead connecting it, but let me just try and touch it up and see. So we clear that up. And now it looks better. Okay, it might have just been hot glue. Maybe that was false alarm. But very same, let's go ahead and measure the coil resistance across the actual motor itself. You can see that there, right? So we're probing the motor now. And I see 16 ohm. Oh, that means we gotta take the other one apart, doesn't it? Oh, really? These motors ought to have the same resistance. So let's see. We measure it down there at 16. We measure it up here on these blue and white leads. It's also 16. Okay, that's just weird. I would expect this wire to have more resistance because it's so thin. I guess expectations can be wrong. Moral of the story. So, let's just start assembling it again. Hope that was the end of it. The end of the weirdness. Okay. Okay. That's it. We cleaned up the inside of this. I'm pretty confident in this one now. So I guess we'll just start screwing it back. We gotta get our gears back out. Blech. Let's turn off the multimeter since we're not using it. Come out a little bit. Alright. I sure love doing screwdriver stuff. This part's pretty simple. You just 3 screws, put it back. Okay. One more screw and then we're done. Done with this one. We'll do our little sanity check again. We're gonna measure the coil resistance, make sure I didn't like sever any wires or anything when I closed it. That would be tragic. For this one, we were measuring around 16 ohms over and over. Now we're measuring 11. It's just weird. Why is it awesome? Why is it jump? It is beyond me why it keeps changing, but that's frustrating. We'll just hope it works. And then if we measure this one again, it's still 30. I don't know, man. Maybe we'll know something's up later, but for now, I suppose we just keep it pushing. We just keep seeing how far through this we can go. But that's the 2 drive pods. So I guess now it's time to pull out the rest of the Roomba, put these back. So we're gonna need to get out all those trays that we used to take it down back in episode 0. And it's just gonna be a bit of a slog to get all these things back assembled. Before we do that, double check what you can see. This is what the Roomba looks like. Now, I'm going to give you a better view real quick and explain some of what I did when you weren't watching. So if we look at this sort of circuit, this is the main control for the Roomba. So the manufacturer has these holes that we're gonna try and route these cables that we just put in through, because these go right under here. And if you look, that lines up pretty darn well. So we're gonna try and just route that through the case hole that is already there. And these are where I've inserted the hacks. So you'll see these areas. This is the normal path that the manufacturer put in. This connects to the blower motor that's on the back. So it's got a red and a black lead, these go through. It's also got a ferrite core. I'm guessing that's because, you know, that sort of carpet brush motor, that's gonna be a higher static sort of generating system. So this just stabilizes that system from ESDs. And you'll notice that it wraps around and through it, and then it kind of comes out. This is where it plugs into the actual circuit board. This is where it gets the signal. So what I did was I routed the signal out through here, and then the blue is going to connect to our control system. That's going to be the part that we can swap in and out. So these are for the blower right here. You see these routed, or no, these are from the other side. These are for the blower. These two are for the blower motor. And then these come from all the way over here. This is where we inserted our hacks. So this one goes to the agitator, that sort of brush that brings everything in towards the center where there's suction. And then I just routed it through here where there's already a plastic channel. So really the thing to do right now is try and get these the drive motors in. So we'll need to start reassembling the top, and the drive motors we'll just screw in from the bottom. I want to screw in the drive motors first, just so we can really route the cables through, make sure that any extra allowances we need for wires or anything are granted. So this should be the left one, so we're going to give it a flip. We see where everything hooks up. We got our target. We're going to try and get these wires through the hole first. And that was not too painful. It was actually pretty easy. And you notice these wires are way longer than what we're actually going to need at the end of the process, but it's good to have extra. And then this pod just keeps sliding, clicks right into place. I'm looking at the wires that came through. I'm making sure everything looks healthy, like it's not getting crimped. I really don't want anything to get like squished wrong or anything, so do that. Suspension still works. Great. And so if you remember when we took it apart, there were 3 of those brass colored screws that were holding these in. So we're gonna go find those and then we're gonna install it. So So here are all my trays that have those parts. We are looking for the brass colored screws. And we found them. 1, 2, 3. Let's see if I remember where they go. Oh, buddy. I'm gonna guess one goes here. One goes here. Yeah, you notice how I said yes? So I'm not sure, but looks like that went in pretty resistance free. Taking another guess. Yeah, it looks like these are fine. There's not like crazy resistance or anything. And one more through here. If I wanted to be real thorough, I'd probably watch back the video where I took it down just to be sure, but But now, as you see, we've got our hack wire coming out, so that's for one of the driveway hacks. And then we've got these. I should probably label these. It'd be best practice to add some little tape labels or something. Making sure this circuit board's still sitting pretty. This is going to be a chore to get everything back in place. There's a lot of moving parts here, so we'll burn that bridge when we cross it, I guess. Actually, no. Maybe right now is a good time to burn the bridge. Yeah, there's a lot of very nice slots that it goes into, so it's not too hard, but still a bit of aligning and finagling to do. There we go. So that's snapped right back in. We got our wire coming out still. Flip. And now we take this pod, we route the wires through. And again, I'm putting the wires through the pathway that I want them to go first. So that way when I flip it, you'll see it from the other side this time. So pilot the wires through, and they start coming out. I'm gonna gather them and pull them. And I just keep pulling them, keep pulling them. Nice and snug. Fits like a glove. Now it's time for 3 brass screws. Brass colored. I don't think they're actually brass. That'd be kind of crazy. Maybe they're just normal color-coded screws. And I think we mounted these right on the other side, so I'm just mirroring the screw pattern. There's no issues so far, so I think this is all good and well. And alrighty, so now if we look at the top, we got our wheels back. We got those sweet, sweet wheels back. They do both compress the same amount. They both roll, and it's got suspension now. So, oh, these wires are a bit of a mess, but it's okay. It's okay. We got this all on deck. I'm just kind of looking. So right now looks like the most convenient way to do this, because I don't know that I can wire this all the way out and then up and still have enough length. I think I'm gonna have 2 holes that I want to drill inside this the roof, so that I can route the wires accordingly. So, I mean, that's really enough for one episode, I think. It was pretty long, but we actually got some work done on the Roomba. We got all these wires coming out. I know it looks like a mess, but next episode we'll actually be starting on the custom control circuit, and then we'll be ready to go.